Welcome to the course on Python for data analytics, machine learning and generative AI. In this video, we are going to learn about tuples in Python, the most versatile data structure in Python. We will be covering what is tuple, immutable laws of tuple, how to build a tuple, assessing the items by index, creating subtuples with slicing, renovating a fixed structure, packing and unpacking, and iterating through the structure. Python tuples represent ordered collections designed for stability rather than change. Once created, their elements cannot be modified, added, or removed, which makes tuples well suited for fixed data sets, configuration values, and records that should remain intact throughout program execution. They use parentheses, support indexing, and slicing like list and can store mixed data types. Because of immutability, tuples are generally more memory efficient and safer to use as dictionary keys or elements of sets. Conceptually, tuples function as a structural blueprint defined once, relied upon consistently, bringing predictability and integrity to Python programs. Let's see the Python's core data structure, the tuple. Think of a tuple as a secure container designed to hold multiple values together under a single name. Like list, tuples can store different types of data and their elements follow a clear, predictable order. However, tuples come with an important distinction that shapes how and when they should be used. Let us look at the example shown here. My tuple apple, banana and cherry are assigned to my tuple. In this line of code, three items apple, banana and cherry are grouped into a tuple using round brackets. The order matters. Python remembers that apple is the first element, banana the second and cherry the third. You can access these values using indexing, just as you would do with the list. For instance, my tuple of 0 will return apple. What makes tuples fundamentally different is immutability. Once a tuple is created, its contents cannot be altered. You cannot replace banana with mango, and you cannot add a new fruit to the tuple. Any attempt to do so will raise an error. This unchangeable nature is not a limitation, it is a design strength. Consider a practical example. Suppose you want to store the coordinates of a location, such as 12.9716, 77.5946 for Bengaluru. These values should not change accidentally during program execution. A tuple ensures data integrity. Similarly, tuples are ideal for fixed records like RGB color values, example 255,0,0, or configuration settings that must remain constant. In essence, tuples follow two fundamental rules. They are ordered and unchangeable. These rules make tuple reliable, predictable, and efficient for representing staple collections of data in Python programs. The three immutable laws that define how Python tuples behave. Understanding these laws is essential because they explain not just what tuples are, but why Python programmers rely on them in specific situations. Let us begin with the first law. Tupules are ordered. When we say a tuple is ordered, we mean that every element has a fixed position, known as an index. Python starts counting from 0. In the example shown, apple is at index 0, banana at index 1, and cherry at index 2. This order is preserved throughout the life of the tuple. You can always access items predictably using indexing, such as my tuple of 1, which will consistently return banana. The second law is the most defining one. Tuples are unchangeable or immutable. Once a tuple is created, its contents are locked in place. You cannot add a new element or remove an existing one or modify values inside the tuple. The padlock symbol on the slide captures this idea well. For example, if a tuple stores configuration values, coordinates, or fixed records, Python guarantees that these values will remain untouched unless the entire tuple is replaced. This immutability makes tuple safer for critical data and more efficient in memory usage. The third law states that tuples allow duplicate values. Unlike sets, tuples do not enforce uniqueness because they are indexed collections. The same value can appear multiple times at different positions. The example shown, apple, banana, cherry, apple, is perfectly valid. Each occurrence of apple is treated as a separate element identified by its index. Tuples in Python can be created in multiple ways and are capable of holding elements of different data types, including other tuples or list. One of the simplest methods of creating a tuple is by literals, where elements are placed inside parentheses. For example, a tuple can be created as within parentheses apple, banana within double quotes, which stores two string values. Tuples also support mixed data types as seen in 5, welcome, 7, geeks, where integers and strings coexist in a single tuple. Another common method of creating tuple is by using the built-in tuple constructor, which allows conversion from other iterable data types. A list such as 1, 2, 4, 5, 6 can be converted into a tuple using tuple of my underscore list, preserving the order of elements. Similarly, when a string like geeks is passed to the tuple constructor, each character in the string becomes an individual element of the tuple, resulting in G, E, E, K, S. These methods make tuples easy to construct and useful when working with fixed, ordered collections of data. When creating a tuple with only a single element in Python, it is essential to include a trailing comma after the item. Otherwise, Python will not recognize it as a tuple. For example, writing within parentheses within double quotes apple correctly created a tuple containing one element, and checking its type confirms that it belongs to the tuple class. However, if the comma is omitted and the value is written as apple within parentheses within double quotes, Python interprets it merely as a parenthesized string, not a tuple, and the type checks return a string instead, not a tuple. So make sure there is a comma which has been inserted. This small but critical synthetic detail distinguishes a single item tuple from a symbol expression enclosed in parentheses, making the trailing comma mandatory when defining tuples with just one element. Tuple elements in Python can be accessed using their index positions by placing the index number inside square brackets, and it is important to remember that indexing starts at 0. For a tuple such as apple, banana, cherry and orange, the element apple is at index 0, banana at 1, cherry at index 2 and orange at index 3. Python also supports negative indexing, which allows elements to be accessed from the end of the tuple. In this case, -1 refers to the last element orange, -2 refers to cherry, -3 to banana and -4 to apple. For example, if this tuple is being assigned apple, banana, cherry, accessing this tuple of 1 returns banana, while accessing this tuple of -1 returns cherry. This indexing mechanism makes it easy to retrieve specific elements from a tuple, whether counting from the beginning or from the end. Slicing in Python allows you to create subtuples by specifying a range of index positions, returning a new tuple that contains only the selected elements. The slicing syntax follows the format of tuple within square bracket starting till end, mentioned as start is to stop, where the starting index is included but the stopping index is excluded. For example, given the tuple apple, banana, cherry, orange, kiwi, melon and mango, using this tuple 2:5 returns the elements from index 2 up to but not including index 5, resulting in cherry, orange and kiwi. If the start index is omitted, slicing begins from the first element. So, this tuple square bracket :4 returns apple, banana, cherry, orange. Similarly, if the stop index is omitted, slicing continues until the end of the tuple, as seen in this tuple 2: within the square bracket, which produces cherry, orange, kiwi, melon and mango. Slicing also supports negative indexing, allowing selection relative to the end of the tuple. For instance, this tuple of -4 is to -1 returns orange, kiwi, melon. This slicing mechanism provides a flexible and efficient way to extract portions of a tuple without modifying the original data. In Python, you can verify the contents of a tuple by checking both its length and the presence of specific items. The total number of elements in a tuple can be determined using the built-in length of function. For example, if this tuple is being assigned apple, banana, cherry, then calling length of this tuple returns 3, indicating that the tuple contains 3 items. In addition to checking the length, Python allows you to test whether a particular element exists within a tuple by using the in keyword. For instance, the expression apple in this tuple evaluates to true if the item is present, and this condition can be used in an if statement to perform an action when the item is found. These operations make it easy to inspect tupules and confirm both their size and their contents. Tupules in Python are immutable, which means that once a tuple is created, its elements cannot be changed, added or removed. This immutability ensures data integrity but also means that tupules cannot be modified directly. However, if changes are required, a common workaround is to create a new tuple with the desired modification. This is typically done by first converting the tuple into a mutable data type such as list, making the necessary change to the list, whether updating values, adding new elements or removing existing ones, and then converting the modified list back into a tuple. In this way, although the original tuple remains unchanged, a new tuple reflecting the updates can be created and used. Although tuples in Python are immutable and cannot be modified directly, changes can still be made by using a simple workaround that involves converting the tuple into a list, performing the required operation and then converting it back into a tuple. For example, to change an item, consider the tuple x, which has been assigned values apple, banana and cherry. This tuple is first converted into a list using list of x assigned to y. Then the element at index 1 is changed to kiwi using y of 1 is equal to kiwi, or kiwi is assigned to y of 1, and finally converted back into a tuple with x assigned the value of tuple of y, and finally converted back into a tuple where tuple of y is assigned to x, resulting in apple, kiwi, cherry. To add an item, the tuple containing apple, banana and cherry is again converted into a list and a new element such as orange is added using y.append of orange. Converting this list back into a tuple produces apple, banana, cherry and orange. Similarly, to remove an item, the tuple is converted into a list and an element like apple is removed using y.remove of apple. When the list is converted back into a tuple, the result becomes banana and cherry. Through this approach, you can effectively change, add or remove elements while maintaining the immutability principle of tuples by always creating a new tuple. Packing and unpacking are advanced but very useful techniques when working with tuples in Python. Packing refers to the process of placing multiple values into a single tuple. Whenever a tuple is created, Python automatically packs the values together. For example, when we write fruits, where the value of apple, banana and cherry is assigned to it, the three string values are packed into a single tuple named fruits. Unpacking is the reverse process where the values stored in a tuple are assigned to individual variables. In Python, this can be done by listing the variable names on the left hand side of the assignment and the tuple on the right hand side. For instance, using green, yellow and red assigned to fruits assigns apple to green, banana to yellow and cherry to red. Printing these variables confirms the assignment with green displaying apple, yellow displaying banana and red displaying cherry. It is important to note that the number of variables used for unpacking must exactly match the number of elements in the tuple. Otherwise, Python will raise an error. This feature makes tuple especially powerful for clean and readable multiple assignments. Unpacking in Python allows you to assign multiple values from a sequence such as list or tuples to variables in a single line of code. When the number of values is greater than the number of variables, Python provides a flexible solution using the asterisk. By adding asterisk to one variable, that variable will collect all remaining or leftover values and store them as a list. A key rule to remember is that only one starred variable is allowed in any unpacking assignment, but it can appear at the beginning, middle, or end of the variable list. For example, consider a tuple of fruits, assigning the value apple, banana, cherry, strawberry, and raspberry. When unpacking it as green, yellow, star red, which is assigned to fruits, the variable green receives apple, yellow receives banana, and the starred variable red collects the remaining values as a list containing cherry, strawberry, and raspberry. Even though the original data structure is a tuple, the starred variable always results in a list, which makes it convenient for handling an unknown number of extra elements. Start unpacking also works when the collection happens in the middle of the assignment. For instance, with the tuple apple, mango, papaya, pineapple, and cherry, unpacking it as green, star tropic, red, which is assigned to fruits, assigns apple to green, cherry to red, while tropic gathers all the values that has been between the list, which is mango, papaya, and pineapple. This ability to flexibly capture remaining elements makes the asterisk a powerful tool for writing clean, readable, and adaptable Python code, especially when working with sequences of varying lengths. Iterating through a tuple in Python is straightforward and can be done using standard looping techniques. Since tuple are ordered collections, you can access their elements sequentially using a for loop. The most common and recommended approach is to loop directly over the items in the tuple. For example, given a tuple such as apple, banana, and cherry, a symbol for x in this tuple, loop allows you to access and work with each element one by one without needing to worry about index positions. This method is clean, readable, and ideal when you only care about the values themselves. Another way to iterate through the tuple is by looping through its index numbers. This approach uses the range of function together with length of to generate a sequence of valid indices for the tuple. For instance, using for I in range of length of this tuple lets you access each element by indexing, such as this tuple of I. While this method is slightly more verbose, it can be useful when you specifically need the index value. For example, when tracking positions or performing index-based operations. In most cases, however, looping directly over the items is preferred for its simplicity and clarity. Tuples in Python can be combined and expanded to form larger structures using symbol operation. One common operation is joining tuples with the plus operator. When you use plus, Python concatenates two or more tuples and returns a brand new tuple containing all their elements in order. For example, if you have tuple 1 where you have values a, b, c and tuple 2 with values 1, 2 and 3. Combining them with tuple 1 plus tuple 2 produces a new tuple a, b, c, 1, 2, 3. This operation does not modify the original tuple, which preserves the immutability of tuple data. Another useful operation is multiplying a tuple with the asterisk operator. Tuple multiplication creates a new tuple by representing the contents of an existing tuple a specified number of times. For instance, given apple, banana and cherry in fruits, multiplying it by 2 results in new tuple apple, banana, cherry and again apple, banana and cherry. This technique is especially helpful when you need predictable repetitions of data, such as initializing patterns or creating fixed size sequences. Together, tuple joining and multiplication provide simple yet powerful ways to assemble larger structured collections while keeping tuple behavior consistent and immutable. Let's summarize the content. Use a tuple when data should not change after creation. Immutability is important. You are storing heterogeneous data, different data types in one record. The collection needs to be used as a dictionary key, where the tuples are hashable. Slight performance gains matters. Tuples are a bit faster and lighter than list. Use a list when you need mutability, which is frequent add, remove or update operations. You are also storing homogeneous data, similar types of items. You need in-place storing. You can use using .sort. The collection size or contents are expected to change over time. So let's now open Jupyter Notebook and write some Python code together and bring the concept of Python tuple concepts to life. Thank you.